Okay, today is October 7th. In RTI, you're finishing the Limits and Continuity AP style review. So we did all of the multiple choice last time, except we skipped this one. I numbered it number 8. It's numbered 16 from the AP exam that I stole this question from. So remember, since the first 30 multiple choice questions, this is the one we did in RTI last time.
Oh, we have the RTI stuff? Okay.
Yeah. You were here that day, right, when we started this? Yep. The first 30 questions on multiple choice on the AP exam are no calculator, so this one you would not get your calculator for. Okay. We had not gotten to finding limits with absolute value, but now we do. We know we have to split it up as a piecewise function. So if I just take this, I can rewrite that as a piecewise function. And remember, your work is not graded on multiple choice, so we try to do things quickly and efficiently. We take the positive version when whatever is inside of my absolute value bars, which in this case is x minus 3, whenever that's greater than or equal to 0, so that's when x is greater than or equal to 3. We take the positive piece of that, and we take the negative piece of the absolute value bars when x would be, oops, that should be 3. I just wrote it wrong. When x is less than 3. So this can really be simplified, this function. Okay, if I look at this piece right here, I have positive x plus 3 over positive x plus 3. Anything over itself, that's really just 1. And here, this piece, the opposite of x minus 3 over x minus 3, that's really the same as negative 1. Okay, so you can kind of simplify your equations there. So that's just me writing my absolute value as a piecewise function. If you didn't recognize that right away, you would when you go to take the limit, but if you can simplify it, it's going to make your life easier when you go to actually take the limit as x approaches 3 from the left. All right, so which piece here would I use if I'm doing 3 from the left, my left-hand limit? Top or bottom? Bottom, yep, 3 from the left would be everything less than 3, so it's just negative 1. Okay, again, if you didn't, go from here to here, you can just do the limit as x approaches 3 from the left. You'd recognize to use this piece. And then hopefully once you actually get it in here, you work and you simplify and you see, oh, that's just the same as negative 1. Okay, so that'd be B. Again, that's our method for limits with absolute values, is to set them up as piecewise functions. Alrighty. So you'll have to remind me, did we do this problem, number 10? Yes. Okay. So free response. You don't remember if I said the breakdown, but I'll say it again. So you have the first 2 problems you can use your calculator on a free response. So anytime they're numbered, so like this says question 6. Anytime they're numbered 1 through 2, that means you get to use your calculator. Okay, this is just me numbering the problem, so don't pay attention to that number. Anytime it's 3 through 6, that means that there is no calculator. That was a no calculator question. Okay, so this first one, question 6, we would not get our calculator on this. Obviously the FRQs are usually broken down with like 3 to 4 parts. We're only going to know how to do part D for right now. So I have this function, which is a natural log of x over x for all positive x, because we know I can't take a natural log of negative numbers. This we're actually going to learn tomorrow, this derivative notation. But D says find the limit as x approaches 0 from the left. Okay, so of f of x, so this function. So here's where on an FRQ, you really have to be proper with showing your work and using the right notation. There's no simplifying I can do here. If I go to plug in 0 right away, the natural log of 0 is undefined. Okay, if you think of the natural log graph, it looks like this. It's like our inverse of exponential graphs. So I can't take the natural log of 0. And look at my domain here. It's only defined for values that are greater than 0. So cross this off if you were to try to direct substitute first. You have to make sure you cross that off. Otherwise, and again, get in the habit of using like arrows instead of equals to. So all we could do is just plug in numbers just to the right of 0. So I kind of taught you to do like 4 decimal places. So I would use 0, 0, 0, 1. Okay, you can actually plug that in. Okay. So the natural log of 0.00001. So again, if you know what the curve looks like, the natural log of a really small number here is going to be really, really, really close to negative infinity, or that's kind of where my graph's approaching. It's approaching values all the way down here at negative infinity. So this ends up being negative infinity. And again, you don't have your calculator, so you can't actually like test this out. You have to know this shape of this graph and know kind of like its end behaviors over a really positive tiny number. So that ends up just being negative infinity. Or if you said DNE, because technically limits are values, either of those would be accepted on the AP exam. Okay, I'm going to quick pull up the scoring guidelines to show you before we move on to the next one. This one was from the 2008 exam. So if we go all the way down to question 6. Okay, here's the exact same problem. Part D. Here we get negative infinity or does not exist, and that was just a 1 pointer. Okay. 1 out of 9 points for just that part. Okay. So I've mentioned before, limits don't show up a whole lot on FRQs, but they can. This next one is a continuity one. This one's from 2012 exam. Question 4. So again, this would have been on a no calculator portion. All right, here I have the square root function. And the only part we know how to do right now is part C. Let G be the function defined by, okay, so we got a piecewise function here. F of x for when x is in between -5 and -3, and x plus 7 when x is in between -3 and 5. Is G continuous at x equals -3? Use the definition of continuity, that's our 3-parter, I, double I, triple I, to explain your answer. Okay, so first, I need to make sure that G of -3 exists. And when x is -3, I would use my top piece, which is f of x. So I plug it in to this piece. All right, I get to 25 minus 9. I get the square root of 16, so I get 4. Okay, G of -3 exists, and it's 4. Now I have to check if the limit exists. That's my second piece. And since we have a piecewise function here, and it's sectioned off at -3, we're going to have to look at the left hand and the right hand limits and make sure they're approaching the same thing. So I'll do the limit as x approaches -3 from the left, which I would use f of x for that piece because that's defined for everything less than -3. And I got to make sure that's the same as the limit as x approaches negative 3 from the right, which I would use the piece of x plus 7, since that is everything greater than negative 3. Okay. So f of x, we just did that. We just plugged that in there. We just plugged negative 3 in. We got 4 on that side. So here, go ahead, plug in negative 3. Okay. Left and right hand are approaching the same thing. That's good. That means that the limit as x approaches negative 3 of g of x is 4. Okay. G of negative 3 exists. The limit exists. So then part 3, we just have to make sure that g of negative 3 and the limit as x approaches negative 3 of g of x are the same. So what I would show is that these both equal 4. Therefore, g is continuous at x equals negative 3. I put a lot of those ones on the review packet because I feel like this 3-part definition of continuity comes up a lot, whether it's in multiple choice or FRQ. I feel like it's a very frequently shown thing of book reading. Standards quick while you figure that out. I do know there was 2 exams in 2012. Okay. Okay, 1 second. So here for part C, 2 points. 1 considers one-sided limits, so considers the left and the right hand limits. Okay, we showed that that was 4. And 1 point for answer with explanation. So this whole piece right there, that g of negative 3 is 4. The limit as x approaches negative 3 is the same as g of negative 3. They're both 4. Therefore, it's continuous. So 2 points out of 9 for that one. Okay. The next one's very similar, so I'll let you guys try this one. This one's from 2011. Show that f is continuous at x equals 0. And again, we have a piecewise function here. This is no calculator still. So go ahead, start with that 3-part definition. See if you can figure that out. Okay, so you have to solve the equation for n. So basically you're getting n by itself on one side. You're not going to get a number, it's going to have a bunch of variables in it. So basically think of you have a bunch of layers around n. I have this 1/3. So right away I probably times both sides by 3, get rid of that. Then you have this times n. How do you undo multiplication? Division, divide both sides by n. Yeah, go ahead. And then in the end you'll add up kind of adding over the r. Because you're basically just trying to get n all by itself over here and you're taking off all those layers around n. Okay.
For this one, I'm not sure.
Well, right away, once you got the bars by themselves, this should technically still have. So after you do that, you got some here. And so what this says is that the absolute value of something, so the distance away from 0 is less than -6. Do you ever have a distance that's less than -6? No. That was my solution. Yeah, that's what I did wrong. You actually did the algebra part right, but you didn't recognize it was no solution. How are you doing that right?
Plus 3 and then 6 plus 3 and
well, then I added 4. And you can add 4. So we added 2, then we added 3, then we added 4. See it?
Okay.
Yeah, and you can have that. All right. I'm going to start going through this one. Okay. Does f of 0 exist? I would use, when x is equal to 0, this piece. 1 minus 2 sine of 0. Oh, guys, you gotta know sine of 0 is 0. So we get 1. Okay, f of 0 exists, and it's 1. Does the limit exist? Well, another piecewise, so we're going to have to check left side. Which left side, everything less than 0, I'd use that 1 minus 2 sine of x. Is that the same as my right side limit? Which, everything greater than 0, I'd use e to the negative 4x. All right, so we plug in 0 here. Again, we just did that. We got 1. Here we plug in 0. E to the power of 0 is 1. Okay, did we get that far? Good. So is it continuous? Yes, because these are the same thing. But again, we should show that. We should show that f of 0 is the same as limit as x approaches 0 of f of x. They're both 1. Therefore, f is continuous at x equals 0. Over here, you could show 2. Since they're both the same, the limit is 1. That was only a 3-parter. Okay, let's quick look at the scoring guidelines for that one. 2011 exam. I think that's here. My sister took this exam. This was question 4. Nope, question 6. Here it just says 2 points analysis. And what I would assume they mean by that is, again, showing that the left and the side limits are 1, showing that f of 0 is 1. Here's your 3-part definition. Here's 2, here's 1, here's 3. Therefore, it's continuous. Part I, double I, triple I, therefore it's continuous. 2 of your 9 points just from that. Sometime I'll show you guys like the average. Honestly, the average on each is like around 2 to 3 points. It's crazy. Because there's some tough problems, but. Okay, one more. 2007, question 3. So again, another no calculator one. The functions f and g are differentiable for all real numbers, and g is strictly increasing. The table above gives value for the functions and their first derivatives at selected values of x. The function h is given by a little composite function here. H of x is f of g of x minus 6. Okay, A, explain why there must be a value r in between 1 and 3 such that h of r is negative 5. Okay, this is an intermediate value theorem one. We have to explain why there's a number in between 1 and 3, so there's kind of like your interval, that you get an output of negative 5. Okay? So first, in the intermediate value theorem, we have to state that it's continuous. Now, we're literally learning this in 2 days, but if something is differentiable, meaning we can take its derivative, then it's continuous. So for right now, I'm telling you, h is continuous. This is like the first part you have to show. Okay, second part you have to show. And I always start, so think of this as like the interval 1 to 3. I always start by finding the outputs at my endpoints. I got to find h of 1 and h of 3. All right, now h of x is f of g of x. If I want to find h of 1, I'm going to plug 1 in for x. Now with these composite ones, you kind of have to start inside here and I have to find g of 1, and that's actually what my table is going to tell me. Okay, so how we read this table, here's all our x values. And then for g, here's all my outputs. So g of 1 is 2. Then I have to find f of 2. So now I'm looking over here. F of 2 is 9. 9 minus 6, we get 3. Okay. H of 3, again, h of x is f of g of x. I'm going to plug 3 in for x. Start in here. G of 3 is 4. F of 4 is negative 1. Minus 6 is negative 7. Okay. So this helps us. Now we can see that this value of negative 5 that they're trying to get us to explain why we would have an input that would give us that output is in between the outputs of my integral. So you would say h of 1 is less than or equal to negative 5, which is less than or equal to h of 3. That's like the second thing you have to show in order to conclude or use. So the hypothesis is met for this theorem. So therefore, the intermediate value theorem guarantees there exists or there is at least one. I'm just going to use the variable they used, r, such that h of r would be negative 5. Okay. So there is an example of the intermediate value theorem. If you just quick glance at B, anytime there's like an existing, like explain why this exists, it hints at one of your big 3 theorems, and B is one of our second theorems we're going to learn. Okay, I'll quick pull up the scoring guideline for that one. What year was this one? 2007, question 3. Oh, that's just it. No, that's all the questions. Ooh, this one there was 2 forms again in 2007. Let's see if this one. Nope, that's not right. There we go. Okay, so you can see here, you would get a point for finding h of 1 and h of 3, and then a point for your conclusion using and referencing the intermediate value theorem. And obviously your conclusion has to make sense. Here's the part about how h is continuous. And since negative 5 is in between those, therefore the intermediate value theorem guarantees that. Okay, I think that completes that packet. So I'm going to stop my video quick.